Good morning, everyone. My name is Nurfifa Fikrasuti and my lecturer, Mr. Habibur Muhaimin. We are from Biomedical Engineering, Bandung Institute of Technology. Today, I would like to present our research about respiratory rate estimation using 3 respiratory-induced variations on photoplethysmogram. Respiratory rate is one of the clinical signs that usually used to monitor COVID-19 mortality. It's commonly measured using capnography or impedance pneumography. The mechanical process of the respirations is also influence the PPG signal. It affects the PPG signal in 3 ways: baseline wonder, amplitude modulations, and frequency modulations. So there are several methods that already developed to estimate respiratory rate from PPG signal. Here we group it into pre-processing process, signal extraction process, RR estimation methods, and the signal length. For the signal extraction methods, there are several methods that using 3 respiratory-induced variations as we use here in our paper. There are also methods that using EMD and EEMD. For the RR estimation methods, there are methods using DFT, FFT, multiple autoregressive model, autoregressive and power spectral density, principal component analysis, wavelet transformations, and many more. For the signal lengths are variative from 10 seconds to 2 minutes. The data that we use in our paper is from capnobase that includes 42 signal, PPG signal, and capnograph as the reference. We also compare respiratory-induced variation-based method with FIR digital filtering-based methods. For the first methods, we use the PPG with the RR from 4.02 to 64.8 BPM, while the seconds we use 6 to 60 BPM RR range. Here are some parameters that we use to evaluate our algorithms. And overall, our algorithms consists of peak and trough detections, artifact detections, respiratory signal extractions, and RR estimations value. For the peak and trough detections, we use PPG delineator from Umar Farouk's that based on first derivations of PPG. PPG is very sensitive with motion artifacts. So we include the artifact detection algorithm here in our algorithms. We detect the clip sample of PPG signal, flat line, and a pulse with periods of either more than 2,400 milliseconds or less than 230 milliseconds. For the respiratory-induced variation-based method, there are 3 main parts. The first is extraction of respiratory-induced variation signal, linear interpolations, and for estimation RR value, we split into 2 different methods. The first is based on the fusion of RR value, and the next is the fusion of the respiratory-induced variation signal. Extraction of respiratory-induced variation signal is done by using the peak and trough locations that we already detect in the previous sections. Respiratory-induced amplitude variations is the amplitude difference between 2 successive trough and peak. Respiratory-induced frequency variations is the time series of the time distance between 2 successive peaks. Respiratory-induced intensity variations is the time series of the PPG upper envelope. Linear interpolations is the sampling of unevenly sampled respiratory-induced variation signal to the evenly sampled signal with a sampling frequency of 4 Hz. Next, estimation of respiratory rate value is done in frequency domain. The RR value was calculated as the frequency where the spectrum is maximum. For the first methods, we use fusion of the RR values. There are 2 different methods that we would like to compare here. The first is smart fusion that comes from the same topic. It calculates the RR by the mean of the 3 respiratory rate values if the standard deviation is less than 4 breaths per minute, while hybrid median filter 1 is come from the different topics. It previously fuse the heart rate value from the several devices. Here we calculate the RR values by using the median of the RR value at the present segment, at the previous segment, and the estimated RR in the previous segment. As the comparisons, we use the method using fusion of respiratory-induced variation signal. The first method is average fusion. It fuses the signal by calculating the average of the three respiratory-induced variation signal. The hybrid median filter here is the same as before. The only difference here are in the output and the input. The input and the output here is respiratory signal. The next two methods is come from the robotic topics. Basically, it multiplied the three respiratory-induced variation signal with the three different weights and then sum it together into one signal. The first method calculate the weight using variation of the signal, and the second calculate the weight using variations and cross correlations of the signal. Here are the peak and trough detection algorithm evaluations. From this table, we can see that peak detection algorithm is good because it has more than 90% sensitivity and positive predictive. From the scatter plot below, we can see that the peak detection algorithm is better than the trough detection. It happened because of in some PPG segment, there are venous pulse influence in the trough occasions. Here are the RR estimation methods evaluations. From this table, we can see that Smart Fusion has the best performance based on the error, but it produced the less total estimated RR. From this table, we can see that hybrid median filter 1 on RR value is the comparable method to the Smart Fusion because it increased the total estimated RR by the cost of the error. Here are the artifact detection algorithm evaluations. From the scatter plot, we can see that our algorithm can reduce about 20% of the error that more than 4 breaths per minute that might be caused by artifact in PPG signal. In our paper, we also evaluate the influence of the segment length to our algorithm. From this table, we can see that the longer segment that we use, the error will be lower. And this is the example of the PPG signal that the RR is changing more than 5 breaths per minute in a period of respiration. From the result, we can see that the longer segment that we use, the less sensitive of algorithm will be. From our research, we can conclude that hybrid median filter can increase the number of RR estimated values by the cost of higher error matrix. And the longer segment that we use, we will get the lower error matrix by the cost of the less sensitive of RR change. Maybe that's all our presentation. Thank you for your attention. Good morning.